One of the first things you're going to run into in a physics class that can be mildly confusing is the differences between distance and displacement. So distance is a scalar quantity, so it doesn't depend on direction, while displacement is a vector, and it has a direction, and it can be negative. So when you're measuring a distance, this is the kind of thing that's going to show up on like an odometer for your car or a step counter on your iWatch or what have you. So this is the actual distance, the actual length of ground that you've covered. And then displacement only depends on your beginning point and your end point, and not anything that you've done in between. And so displacement is usually given as your final point, so x final minus x initial. So these are just the 2 points that you're at the beginning and the end. Whereas in a distance, you're just going to add up each of the different legs of the trip. So that's probably still a little bit confusing. So let's go ahead and jump into a couple of examples. And you're going to run into a lot of questions like this in an introductory physics class, and they will most likely ask you for the displacement and the distance within one question. All right, so in this question, we have a truck that's driving east, and then he turns north after driving 3 kilometers. The truck then travels for 5 kilometers. Then they realize that they pass their destination and turn around. And then after driving 2 kilometers south, the truck stops, and we want to know the displacement of that truck, the magnitude and direction, and the distance that it covered. So we got the grid background here, so we can go ahead and draw out our plot. Okay, so now we have our grid that's going to represent the plot for the directions that this truck is driving in. So we'll say that 3 of these little squares equals 1 kilometer. And we have our y-axis here and our x-axis. However, we're dealing with directions. So we're talking east, west, north, and south. So each axis is going to correspond to a direction. So just think about looking at a map. Our positive y-axis is going to be north. Positive x-axis is going to be east. Negative y is going to be south. Negative x is going to be west. And since we're dealing in units of kilometers, we'll just say that, each of these marks represents 1 kilometer. So this is in kilometers. All right, so now we can start thinking about where this truck is driving. It says it starts out driving east and drives for 3 kilometers, or turns after driving 3 kilometers. So let's go ahead and go east for 3. And then we're going to turn north and drive for 5 kilometers. So that's 1, 2, 3, 4, 5. And then they realize they passed their stop and they're going to turn around and drive south for 2 kilometers. So now we're going back down 2. Okay, so our end point is about here, right? So our beginning point was at the origin, and this is our end point. So let's figure out what the displacement is and then what the distance is. So first of all, we'll note that this point going from the origin to the end point is the displacement vector. So because this is in 2 dimensions, we'll go ahead and say it's delta S, since it's not x or y, but then it has an x component and a y component, right? So here's our x component, delta x, and our y component, delta y. So our delta x is just 3, right? So it's moved a total of 3 kilometers to the east. So the end point is 3 kilometers to the east. Delta x equals 3 kilometers. And delta y, so initially we went 5 upward, but then we went back down 2. And the end point is the one that matters. we're now at the 3 mark here for our delta y. So delta y is also 3 kilometers. And to find the magnitude, delta s, which is a vector, we want to find the magnitude of this vector. All we have to do is say the magnitude of delta s is going to be the square root of delta x squared plus delta y squared. So let's go ahead and plug in our values. That's just going to be 3 kilometers squared plus 3 kilometers squared. So that's going to be 9 plus 9. So we have square root of 18. And that is 4.2 kilometers. So that means the magnitude of our displacement is 4.2 kilometers. And then we want the direction. And when they ask for the direction, what they mean is to get this angle here. So we're just doing some trigonometry, right? We just found the hypotenuse of a triangle. And now we just want to find this angle here. And in these types of problems, usually what you have is the x and y components. We now have the hypotenuse as well. But what we'll go ahead, or we'll say the angle here is equal to the inverse tangent of the y component over the x component. So delta y over delta x. And that's just because delta y over delta x equals the tangent of the angle. So when we're solving for the angle, we use the inverse tangent. Okay, so plugging in inverse tangent, 3 kilometers over 3 kilometers. This is just going to give us 45 degrees. And we pretty much already knew that if we remember trigonometry. If we have a triangle with 2 legs that are the same length, then the angle is going to be 45 degrees. But even if you don't know that, you can find it using theta equals inverse tangent of delta y over delta x. So now we have the magnitude and the direction for the displacement of this truck, right? So that's our displacement. And now let's just find the distance. This is going to be a lot easier. So we're just adding together each leg of the trip that this person took, or that this truck drove. So that's just going to be, so distance equals, we drove 3 kilometers east, right? So 3 kilometers plus 5 kilometers north. And then we went 2 kilometers south. So we're just adding these together. That's 5, 6, 7, 8, 9, 10. So that's 10 kilometers as your distance. So distance is a little bit easier to find. And again, the direction doesn't matter. So you're just adding up the actual distance that you drove. And this is what the odometer of the truck would say if they had, well, first, if it were measured in kilometers, and also if you had started off at 0 when you started this trip. So that is how you find the displacement and the distance. And you'll most likely run into questions that ask for both at the same time. And then sometimes with these types of problems, you're also going to be asked for the speed versus the velocity, or you'll have similar problems, and we'll go ahead and do another video covering that as well.